So here I will discuss about zirconia oxygen analyzer. Okay. So zirconia, what is zirconia oxygen analyzer? Zirconia is one of the few compounds that actually become conductive at high temperature and more conductive as its temperature increases. Zirconia starts out with a very high resistance at room temperature greater than 1 trillion ohms per centimeter, having less than 1000 ohms per centimeter resistance at 1000 degrees Celsius and become a very good conductor. Okay. Now see the construction of zirconia gas analyzer. The zirconia gas analyzer consists of a solid electrolyte like zirconia which exhibits conductivity of oxygen ions at high temperature. Porous platinum electrodes are attached to both sides of the zirconia element to be heated up. This is the diagram of zirconia gas analyzer. Zirconia gas analyzer basically consists of a zirconia element which is centrally placed. And here you have two electrodes. See, zirconia element is centrally placed and there is two electrode, cathode and anode. Okay. And they are made of porous platinum electrode. They are made of porous platinum electrode and are attached to the zirconia element. And this element, this zirconia element is to be heated up. Okay, so see the principle. Gases of different partial oxygen concentration are brought into contact with the respective surface of the So see, gases of different, see the working principle of zirconia gas analyzer. Gases of different partial oxygen concentration are brought into the contact with the respective surfaces of the zirconia. The device acts as an oxygen concentration cell. This phenomenon causes an electromotive force to be generated between both electrodes according to Nernst equation, and it is proportional to oxygen concentration. Now see the working of the zirconia gas analyzer. Heating the element So see the working of zirconia gas analyzer. Okay. So see here. So see here, this is the diagram of zirconia gas analyzer. Okay. So gases of different partial oxygen concentration are brought into contact with the respective surface of the zirconia. Okay. So see here you have a zirconia element in the middle, and to this element porous platinum electrode are attached here. Okay, and this assembly is placed in a chamber where we are having gas of higher oxygen concentration on one side and gas of lower oxygen concentration on the other side. Okay, so see the diagram. So see here we have a zirconia element, and to this element porous platinum electrode are attached, and this assembly is placed in a chamber where we are having gas of higher oxygen concentration on one side and gas of lower oxygen concentration on other side. So device acts as a oxygen concentration cell. Okay, so the device acts as a oxygen concentration cell. This phenomena causes an electromotive force to be generated between both electrodes according to Nernst equation, and it is proportional to oxygen concentration. Okay, so gas of different concentration, different partial oxygen concentration are made to brought in contact with the respective surface of zirconia, and the device acts as a oxygen concentration cell. Okay, so in this way this device work. Okay, so see the working. So heating the element allows different partial oxygen concentration of the gases to come into contact with the opposite side of the zirconias, creating an oxygen concentration cell. These ions travel through the zirconia's element to other electrode. At that point, the Nernst expression applied to calculate the force by measuring the electromotive force generated between two electrodes. Reference gas on one side and sample gas on the other side. Oxygen ions move from the side with the highest concentration of oxygen to that with the lowest concentration, and the movement of ion generates an EMF or electromotive force which can be measured to determine the oxygen content. So see the working of this zirconia gas analyzer again. So see the diagram. So see here you have a zirconia element, and to this element porous platinum electrode are attached. Okay, and this total assembly is placed in a chamber where we are having gas of higher oxygen concentration on one side and gas of lower oxygen concentration on the other side. Okay, so the device acts as a oxygen concentration cell, and this phenomenon causes an electromotive force to be generated between both electrodes according to Nernst equation, and it is proportional to oxygen concentration. Okay, so this is the working of zirconia oxygen gas analyzer. Okay, now this is the diagram. So this is the figure of zirconia gas analyzer. Okay, so in zirconia gas analyzer, centrally zirconia cell is there, and we have a reference air. Heater element is there to heat the zirconia cell, and we have inlet for reference air and inlet for sample also. Okay, so this is the figure of zirconia gas analyzer. Okay, so see here a process gas. So see the working principle. Here a process gas with an unknown oxygen concentration flows around the, see here, a process gas with an unknown oxygen concentration flows around the outside of heated zirconium oxide measuring cell. A process gas with an unknown oxygen concentration flows around the outside of heated zirconium oxide measuring cell. A reference gas with a known oxygen concentration flows inside the measuring cell. At an optimum temperature, a voltage in millivolt is created between the two surfaces of the cell, which are dependent only on the ratio of oxygen concentration of unknown sample gas and known reference gas. Using air as a reference gas, the measured voltage is a direct measure of the oxygen concentration in the process gas. So this is the working principle of zirconia gas analyzer. This figure represents the instrument of zirconia gas analyzer, and this is the internal structure of the zirconia gas analyzer. Okay, this is the schematic diagram, and this is the instrument. Okay, so what is the working principle? So a process gas with an unknown oxygen concentration flows around the outside of heated zirconium oxide measuring cell. A reference gas with a known oxygen concentration flows inside the measuring cell. At an optimum temperature, a voltage in millivolt is created between the two surfaces of the cell, which are dependent only on the ratio of oxygen concentration of unknown sample gas and known reference gas. Using air as a reference gas, the measured voltage is a direct measure of the oxygen concentration in the process gas. Okay. So here two parameters vary. Therefore, the EMF generated when unknown sample and known sample of oxygen concentration are passed into the zirconium analyzer. So the EMF depends upon the temperature of zirconium, and hence EMF depends upon the temperature of zirconium sensor and depends upon the oxygen concentration of the reference gas. So we are mostly designed a zirconia gas analyzer, and we are going to use a oven to maintain the temperature constant. So hence zirconium sensor placed in a constant temperature oven, and most commonly used reference gas is air. Okay, so here two parameter varies, and the EMF generated and the EMF varies depending on this factor. That means the EMF varies depending on the temperature of the zirconia sensor and the oxygen concentration of the reference gas in the actual device, and hence the zirconia sensor is placed, and therefore the zirconia sensor is placed in a constant temperature oven, and air is generally used, reference gas is generally used as air. Okay, but there are certain limitations using the zirconium gas analyzer. So limitations are flammable gases. In zirconium gas analyzer, flammable gases cannot be used. Flammable gas means gas which can catch fire easily. They cannot be used during the analysis using zirconium, because here we are heating the zirconium oxide. So the element is being heated, so we cannot use flammable gas. Okay, so first limitation is flammable gases cannot be used, and second is sensor degradation occurs if corrosive gas like fluorine based gases, chlorine based gases, sulfate based gases is measured. Okay, now see the advantages of zirconium gas oxygen analyzer. So it can be directly installed. The first advantage is it can be directly installed in a conversion process such as a boiler's flue and requires no sampling system, and it have faster response. Okay, now see the disadvantages. So if the sample gas contains a flammable gas, a measurement error occurs. Okay, so if the sample gas contains a flammable gas, measurement error occurs. So this is the disadvantages of zirconium oxygen analyzer. Okay, so here in this lecture I have discussed about zirconium oxygen analyzer. Thank you.